while you're developing these solutions, right, it's really one can visualize the kind of machine learning metrics you would have in order to measure. But once you go to the field, right, the machine learning metrics are only a helper. At
Yes.
the end of the day, what matters are the numbers to vary the success of the entire solution, right? What are some of the metrics for a project like that? And then how do you even go about kind of measuring? Because in the worlds that we come from, one can create a A/B set, do all of the stuff,
Yeah.
right, on the Amazons of the world, right?
Yeah.
But under these circumstances, you can't do any of that. So,
Yeah.
can you give us a glimpse of what does it mean to measure these solutions, right? Define success. How does one even define success in these cases?
No, I'm very glad you asked this question, Anuj, because this opens a whole Pandora's box, and this Pandora's box becomes even more complicated when you add Gen AI into the mix. So let's first talk about how do we handle the situation without Gen AI, and then we can come to the Gen AI part later.
Right.
Um, so absolutely true. I think a lot of machine learning scientists and engineers do not appreciate that the metrics that they optimize when they build models, or even metrics they use to track performance or so-called success, are not necessarily the metrics that matter on the ground, right?
Yeah.
Typically, a machine learning engineer works with two kinds of metrics. One is the loss function that they use in training, right? And the second is the loss is the not a loss function, but they some kind of objective function that they use to measure the success of their model.
Yeah.
Neither of these metrics actually necessarily correspond to success on the ground, right?
Yes.
Um, so for example, and then even on the ground you have short-term metrics of success and long-term metrics of success. And so let me
Mm.
just give you an example of a simple tabular data problem. One of the problems we work on is in the tuberculosis space, where we look at patients at the time they initiate TB treatment. So they are TB patients, they're about to start TB treatment. You want to predict whether they will complete treatment or not. And this is an important problem because one of the big issues with TB is that people don't complete treatment. And it's well known that if you miss about 10% of your medication, 10%
Mm.
of doses, let's say you take one pill every day for 6 months, you miss 10% of your doses, the chances of getting drug resistant TB increase by a factor of three. So it's very important to take your medication regularly, just like HIV, right? So TB has been a curable disease for the last 100 years, and yet people die of TB. This is one of the reasons. There are other reasons as well. One of the
Sure.
reasons is the population that is afflicted with TB tends not to take their medication on time. They're often migrant workers, truck drivers, people like that, right? They forget to take their medicines, or they start feeling better. The TB symptoms go down. They start feeling better, so they stop. The other symptoms go up, side effects go up, so they stop. So there are a number of reasons, right?
Yeah.
Now, so it's very important that we identify which patients might drop off treatment, or to have a risk score for
Mm.
each patient, saying that this is the risk for this patient to drop off treatment. Because then, if you know patients who have a high risk of dropping off treatment,
Yeah.
your TB health worker force, which is employed by the government, can do intensive counseling to these patients. They can actually go door to door and remind them to take their medicines every day, right? It
Yeah.
goes to that extent. Um, you can't do that at scale, right? Obviously.
Sure.
So you have to identify the most risky patients. So this is, in a sense, a simple binary classification problem from a technical perspective. That is the patient going to drop off treatment or not? That's your target function. It's a binary target, and you have longitudinal data about the patient. You have lots of patient characteristics. You may even have some contextual data about demographics, about where the patient lives, family size, etc., economic status, and so on. You combine all these variables and create a tabular model for this. Now, how do you measure the success of this model, right? And if you give this problem to a machine learning engineer, they would plot a ROC curve. They would look at area under ROC curve, or they would plot a PR curve because prevalence is very low. So
Mm.
some people may think to plot a PR curve and then look at area under PR curve. Both of these are completely the wrong metrics, right? What do you want to do here? Here, ideally, what is the ideal situation? If you had infinite health worker resource, you want to go and do intensive counseling to every patient.
Mm.
You don't want to identify those who are most risky, right?
Yeah.
You want to do it for every patient, and then you don't need AI.
Correct.
So why do you need AI? You need AI because you don't have an infinite health worker
Yeah.
force, right? You have
That
you
is
have to do
easy.
prioritization. You have
Correct.
you have limited resource. You have to do prioritization. So your metric of success has to be dependent on the amount of available resource you have. So let's say you have only enough health worker resource to be able to do intensive counseling to 20% of the patients in your catchment area,
Mm.
not 100%, right?
Yeah.
How do you choose that 20%? If you make a random choice, you get a certain,
Yeah.
then essentially you have a sensitivity or a recall of 20% if you
Correct.
make a random choice. If you have a rule-based model, then your recall may be slightly higher than 20%. If you have
Sure.
an AI machine learning model, your recall may be even higher. So the correct metric here that will measure how much impact you're having on patients, at least the short-term metric, is recall at K percentage, right? Where K is
Correct.
defined by the amount of resource availability that you have, and that can vary from location to location. So you
Yes.
would look at recall at K for each location that you're deploying the model in. So this is one thing. So this is a short-term metric. But then, are you really interested only in recall at K? What are you really interested in? What you're really interested in is if the model is used well, then the number of patients who stop taking their medicine will decline
Yeah.
over time. Now,
Yes.
that's your long-term metric of success, and that's the true metric of success. And that takes time, but you have to be aware that you have to measure that.
Yeah.
So usually, even in the deployment scenario, we look at both short-term metrics that actually capture what's going on the ground, as well as the long-term metric in terms of impact on the people that you're affecting with your AI. So, for example, for this solution, we have early indications that the model is working because we are seeing that in areas where we've deployed it, the rate of not taking medication is going down,
Mm.
right? But it's still
Mm.
very early. It's not yet statistically significant. We can't come out, and sort of say that as a formal result. But it takes time. It takes 2 to 3 years to figure out whether this is actually
Yeah.
happening.
Yeah. Absolutely.